Hey there, my keeper. Welcome. Wilcott tells me you need some information on minerals. Well, you've come to the right place. As you can probably guess, we do a lot of digging around here to keep all these plants going and growing. You see, these guys here can be very persnickety when it comes to what kind of soil we put them in. You put a tulip in a bucket of sand, and well, that tulip isn't going to be very happy about it. So, to get things started, I should tell you that minerals are naturally formed solid chemical substances, and most rocks are made up of two or more minerals. Let me show you a couple of examples. This is a sample of a very common rock called granite. This granite's made almost entirely of three minerals. The whitish-gray mineral is a kind of quartz, the pink mineral is a type of feldspar, and the black flaky-looking mineral is a form of mica. Now, each mineral is made of certain elements, such as silicon, oxygen, iron, and many, many others. There are actually a few thousand known minerals, but only a few dozen that are really common ones. So, how can minerals be identified and classified? By using their mineral properties. The most obvious property would probably be a mineral's color. A mineral's color is really just the type of visible light reflected off it. For example, here's a piece of amethyst quartz. Notice how it has this very distinctive purple color. That means it reflects purple light. Quartz, like many other minerals, comes in lots of different colors. So color, by itself, is usually not the best property for trying to identify minerals. However, color can be a good property to help identify some minerals. Like this next one, sulfur. It has a very distinctive yellow color, but sulfur isn't the only yellow mineral. Also, you should know that some minerals don't have any color at all. They're transparent, like this quartz crystal, or these salt or halite crystals. Some minerals, like these citrine gemstones, have a color and are also transparent. Citrine's actually another form of quartz. Now, another mineral property you want to look out for is streak. Streak is the color of a mineral's powder after the mineral has been dragged across a plate made of porcelain, a very hard material. Often the powder is the same color as the mineral, but not always. For example, the mineral hematite is normally a black or silver gray color, but its streak is red to reddish brown. There are even a lot of dark-colored minerals that have a white streak. Okay, next up is luster. Luster is another property that's used to help identify minerals. It's related to color, but luster is the way light is reflected off a mineral. Basically, you look at whether minerals have a metallic or a non-metallic luster, if they look like a metal or if they don't. Gold and galena both have a very obvious metallic luster. Some types of quartz have a non-metallic glassy luster to them, while other types of quartz even have a non-metallic waxy luster. The very popular diamonds have a non-metallic brilliant luster. Okay, my keeper, let's go ahead and take a quick question to see how much you've picked up. Okay. So now we've taken a look at a few properties such as color, streak, and luster to describe certain minerals. This brings us to our next property, hardness. This is one of the most useful mineral identification properties. It tells us how easily a mineral can scratch a mineral or be scratched by another mineral. Harder materials can scratch softer ones. For instance, a rock might scratch glass. A special scale ranging from 1 to 10 is used to classify minerals by their hardness. A mineral with a hardness of 1 is the softest and can be easily scratched by harder minerals. Minerals with a hardness of 10 are, well, the hardest. Talc, for example, has a hardness of 1. It can be scratched easily with a fingernail. Talc is actually what talcum powder or baby powder is made of, which is pretty soft. So, what's the hardest mineral? Diamond. It has a hardness of 10 and basically is unscratchable by any other mineral. Pretty much every other mineral known fits somewhere in between a hardness of 1 and 10. Quartz, for example, has a hardness of 7, so it can scratch minerals that have a hardness that's less than 7, like pink feldspar. It's got a hardness of 6 and is the most common mineral in Earth's outermost layer, the crust. Now, even though quartz can scratch glass or even steel, quartz is easily scratched by diamond and other minerals whose hardness is greater than 7, like topaz, which has a hardness of 8, or corundum, which has a hardness of 9. Corundum comes in a couple of different forms, such as ruby and sapphire. Now, many minerals with a hardness of 7 or above, such as diamond, topaz, ruby, and sapphire, are not just hard, they're also valuable, especially if they're rare and transparent. These are called gems, or gemstones. Emerald, like the greenish one in this ring, is one common gem with a hardness of about 8. It's a very good thing most gems are hard. After all, it wouldn't make a lot of sense to buy an expensive piece of jewelry if the gemstone could be easily broken and fall to pieces. Many minerals, including gems, often appear in a very visible crystal form. They have a bunch of flat surfaces, and there's a very interesting reason why they look this way. It's because the atoms that actually make up these mineral crystals are arranged in an orderly way. All right, time for us to take another quick question. Okay, so far we've taken a look at the properties we can use for identifying minerals: color, streak, luster, and hardness. But we've got a couple more that you'll want to know about. Another useful property for identifying minerals: density. In order to find a substance's density, we'll need to use a little formula that's not too complicated. An object's density is equal to its mass divided by its volume. An object's density basically tells us just how heavy the object feels for its size. For example, a gold nugget would feel about 4 times heavier than a piece of pyrite or fool's gold if they were the same size. Another helpful property is crystal shape. Some minerals have a very distinctive shape to them, like some quartz crystals. In their natural form, they almost look like they've been cut. But other minerals could have a similar shape. So to make sure a mineral is quartz, you'd want to check some of its other properties. This is a good rule anytime you're trying to identify any kind of mineral. Another mineral identification property relates to how a mineral breaks. For example, mica easily peels off in layers, while quartz looks sort of like broken glass when it breaks. And gold doesn't really break at all, but it can be hammered into really thin sheets or stretched into wire. Another property of minerals is whether or not they will react chemically with another substance, such as an acid. A mineral called calcite, for example, will fizz when acid drops are put on it. Also, some minerals have a distinctive feel, smell, or even taste. For example, talc is slippery. Sulfur minerals smell like rotten eggs. If you've ever been around a sulfur plant, you know how stinky this is. And halite tastes like table salt because, well, it is table salt. By the way, you should never do a taste test without checking with a teacher first, because some minerals are poisonous, or at least may have a lot of germs on them. Okay, our last property for minerals is magnetism, or whether or not they behave like a magnet. So, if some mystery mineral you're testing attracts small iron particles, well, that really narrows down what it can be. For example, it could quite possibly be a mineral called magnetite. All right, Mind Keeper, that's all the knowledge I have for you on mineral properties. Just one last question, and you're off.